Hi Vijay, good morning.
Yeah, good morning.
Yeah, morning. Right, guys. So let's start. Uh, or other will be joining. Okay, so let's say that ACI. So yesterday we have covered that uh, the hardware of MXS 9000. So today we are going to discuss hardware of the controller as well as the before hardware of the controller. We will understand why ACI, what ACI brings into the table, and why we should consider the ACI. Okay. So if we consider the why ACI, what uh, the customer challenges we have currently nowadays. Okay, what is the day-to-day challenges we get in a legacy network? The first challenge we get that physical installation. So in the physical installation, when you bring that, for example, 10 or 15 devices, how you install those devices into the data center and how you configure those devices. When you bring the suppose one or two devices, you just have to install and configure those devices manually, at least the base configuration, before you can take control of those devices from the remote, right? And you have to do the all sort of discovery in the environment to connect those devices in the existing infrastructure via the console. Whereas in ACI has auto discovery mechanism. You just have to uh, plug your device with another device. It will automatically discover through the LLDP protocol, and it will draw one picture for, or draw one topology for your informations and maintain in the that topology will be maintained in the database level itself in the controller. Second is the management configurations. So when you purchase any new device in current scenario, you have to configure the out of band, you have to configure the uplinks. Whereas in ACI, all the configuration will be centralized. You don't have to manage any sort of out of band or uplink configuration for each device. Everything can be done from the controllers. Then software upgrade. Here in legacy infrastructure, you have to do software upgrade one by one, right? If you have 10 devices, you have to connect those devices 10 times remotely. Whereas in ACI, all the configuration software upgrade can be centralized, and you don't have to worry about any leaf and spine upgrade. This controller has ability to push all the configuration on the leaf and spine remotely from single interface, and within a 30 minutes. So here the disadvantage was if you're having three devices, you have to upgrade one by one device, and each device is used to take 45 minutes to 1 hour if everything goes fine, right? Whereas in ACI, if you have 20 devices, right? For example, you can bundle 10 devices one time, you can bundle 10 devices as the second time. You can upgrade 10 devices in 30 minutes, 30 to 45 minutes, here another 30 to 45 minutes. It means rather than upgrading manually one by one, you are upgrading the bundle, and a single go you can upgrade the more than 10-20 devices, which can upgrade within 30 to 40 minutes.
Good morning, Vijay.
Hi. Just give me.
Sorry, Vijay, I just joined. We have just started, right?
Yeah, we just started.
Okay.
We are discussing here why we should use ACI, what ACI is solving in for the customer, what ACI brings into the table, right?
Right.
So these are some challenges which day to day we face that in legacy infrastructure, and this is the ACI provides the flexibility for the engineer to manage your infrastructure. So, for example, if you're having a software upgrade, so currently we do that one by one upgrade for the new devices. In the ACI, you do that configuration from centralized interface. For the large scale configuration, you have to do one by one. For example, if you want to create that one VLAN or on the multiple devices, you have to do one by one. Whereas ACI can be done through the centralized automation. Then hardware replacement. If you want to refresh your hardware, you have the existing hardware 5000 is running, you want to replace the Nexus 9300 something, right? In this case, you have to put lot of effort in order to bring those setup up and running, in order to migrate those hardware from the legacy to the new one. Whereas in ACI, you don't have to worry about the configuration. You just make sure that physical connectivity is up and running fine. Configuration can be centralized from single interface, and within a half an hour, within a 10 minutes, you can bring all the new hardware and you can place the hardware. Then application centric approach. The legacy infrastructure has a network centric approach. Here we have application centric approach. Application centric approach is much more secure than the network centric, whereas in network centric, any to any communication will be by default allowed. In application centric approach, any to any communication will be by default blocked in the network. Then provisioning agility in the network, legacy network nowadays, that's a major challenge we have, that in order to provision the network, in order to bring the new hardware or decommission the hardware or to delete any or create any configuration, this is time consuming for legacy infrastructure. Whereas in APIC, from centralized interface itself, you can do all the kind of activity which you want to do that. Then operation complexity. To manage legacy infrastructure, we need at least, if you're having 100 devices, we need at least minimum 10 to 15 people to handle those 100 devices. Whereas in ACI, you just need few people team, one and few people in data center who need to manage this ACI and who can manage this ACI. For a scalability point of view, the upgrading this hardware itself is one of the biggest challenge we have nowadays. Whereas in ACI, you just have the flexibility to add and remove your hardware based on your scalability requirement. Okay. What modern data center requirement is? What actually you suppose you have 365 application, right? And you have data center which need to be integrated with the cloud. What is the modern data center required? When you design data center, the 10 year back data center requirement was something else. Now after 10 years, data center requirement is something else. And after 10 year data center requirement will be something else. What challenges we face that? So data center must be focused on the applications and data. It must also reduce the operational cost. It must also reduce the capital expenses. It must also provide the provisioning and operational agility, and it will also improve the reliability. That's the key focus when you design the data centers. Also, you must optimize and automate your data centers. These are the key features we look for the in a modern data center deployment. When you design, when you deploy any solution for the customer, these are some aspects we should be considering before deploying the data center, or before deploying any solutions. Okay. Then we come to the why ACI. Okay, just give me a second. Why ACI? So ACI is a solution which has both the option virtual and physical option. It means you can deploy Cisco ACI as a virtual in your data center. You can deploy ACI as a physical in your data center, and it also provides the scale performance for the from your hardware perspective. It means if you're having the Cisco ACI hardware, it can also provide you the best performance compared to your legacy network, because in legacy network there are a lot of protocol which also reduce your hardware performance. So hardware perspective, you are escalating the hardware. It means if you're having the 10 gig requirement, then if you're bringing the 10 gig switch, the full capacity you can utilize in the ACI. You have a single architecture to deliver for the performance, for programmability, for agility, and it will also reduce the complexity. Rather than having a 3-tier architecture and design a lot of different things, ACI has single architecture which will be always valid leaf and spine architecture. You have to care about only the Windows design, nothing else about the ACI. Okay. Then we have application-centric policy model. It means dynamically define the network fabric for the application based on the application requirement. Then you have also automated network fabric for the both virtual and physical workload. It means you have the GTP, dynamic, we can zero touch provisioning in ACI. So you don't have to worry about that fabric setup between leaf and spine. The moment you bring up the physical connectivity, it has ability to self discover. It has ability to self pre-configure between the leaf and spine configuration. Okay, for a scalability point of view, ACI scalability is based on its clusters. It's not like you just deploy n number of devices to the n number of the cluster. Suppose if you have two spine or multiple leaf switches, right? So how many you have DC1? DC1 equal to, I would say, that port 1. Okay. In one data center, one port, you can have max to max 6 spine switches. Okay. And leaf switches is n. Infinity, I would say that. So leaf switches will be depend on the number of the, if I say that leaf, it depends on the number of the APIC cluster nodes. It's not like there is a fixed leaf which you can deploy that, but it also depends on the how many clusters APIC nodes. It means how many SDN controllers you have. Suppose if you have 3 SDN controllers, for example, right? If you're using a 3 SDN controller, you can have only the 80 leaf and spine switches. Okay. If you're having a 5 SDN controller, the number will be totally different for the deployment. If you're having the 7 SDN controller, the number will be totally different. Let me show the scalability guide for the APIC for the ACI. So you can just type your CISCO ACI. Scalability. So different version has different scalability. So if I go to the latest one, 5.2. So this is the scalability guide. You can see this one. So if you're having a 3 SDN controller, it can have total number of the leaf switches 80. Number of the leaf switches per port 80. Number of the port, it means 3 APIC can handle the 6 data center. 6 data center number of the port. Okay. And that including this 6 data center, you should have max total 18. It's not like per port you can have the 18. Okay. Then if you having the 4 APIC cluster, 4 APIC node, it can go for the 200 leaf switches. And the number of the port will be same. If you having the 5 to 6 APIC cluster nodes controller, you can have 300 up to 300 leaf and spine. You can deploy that. If you're having a 7 APIC nodes, you can have 500. So maximum how many leaf and spine you can deploy?
500.
500. And also you need to deploy the 500. You need to have the 7 APIC node cluster. Okay, and maximum 12 data center that can be controlled via the 7 APIC nodes.
Sorry, with the term pod, do we understand it's one data center?
One data center, yes.
Okay.
One DC. Pod 1, suppose you have two data center, DC in Bombay and one is in Hyderabad, right? We call that pod 1, pod 2, but pod 2. And this is for the multi-port technology. If you're having a multi-site, it means one data center is in one country, that's in India. Second data center is in the USA, for example, that we call that fabric. Fabric 1, fabric 2. Pod means you have both the data center in the same region in different availability zone.
Okay.
Okay.
So, the second option scenario is actually a case of a multi-site.
Multi-site, yes.
Fabric 1, 2.
Yeah. But if you see the second scalability guide here, so number of the spine per port total is going to be 6. But 6 spine, 90% of the customer deploy the 2 spine max to max. I would say 98% of the customer deploy that, right? They don't go for beyond the 2 spine and 200 leaf switches as far as I worked on, because number of the leaf and spine is something which Cisco itself suggests that Cisco suggests that this is just a number maximum, but you should be scaling your fabric this much only. You should have the 200, which will be easy for the APICs or something to manage. It will be easy managed for the your op engineer as well, including the ACI. So number of the spine in multi-port fabric, you can have the 64 to 24 total across the 6 port. So number of the effects, how many connect Nexus 2K, how many connects you can connect with the APIC or the ACI switches. This one is the maximum number of the effects port you can have. Maximum number of effects is 20. 20 Nexus 2K devices you can connect if you still have Nexus 2K devices in legacy infrastructure up and running. And
What is this FX?
This is the Nexus 2K FX extension.
Okay.
If suppose you have the, usually what happens is in the legacy infrastructure, we have Nexus 3K, 5K, 7K, right? And we used to purchase the 1 port extension. Suppose you have the 32 port switch. This is the N5K. And if you have the 20 more port requirements, in this case, you not purchase one N5K. That will be expensive. What you purchase here, you purchase some ports, and that port Cisco sell as a Nexus 2K device.
Okay.
Okay. It's a brainless device. It also controlled via the core device. You just bring the Nexus 2K. Nexus 2K will act as a port extension for the Nexus 5K or 7K. You can configure this Nexus 2K from the code itself.
So it will be again auto discovered by the APIC controller and all this. Right?
Yes, that will be, if it is Nexus 9K ACI, that will be done by the APIC controller, nothing else from the CLI. But for the legacy infrastructure, you have to do it manually.
Basically, a stacking of another switch to increase the number of.
Yes. So usually it's not recommended to use effects in a ACI environment, to be honest. But if you have the legacy, effects already up and running in your legacy infrastructure and you want to shift it, that's the reason Cisco suggests that just I'm giving you the option. If you're having the effects in legacy infrastructure, you can still integrate and utilize those hardwares. And for the long run, these specs will be end of life, so you won't be getting that option for long time.
Okay.
Then these are some scalability. How many tenants and all these things you can create. How many gateway you can have in ACI, like layer 3 gateway. You create the SBI, HSRP, those things. How many gateway you can have in ACI. So if it is layer 3, 15,000. If it is layer 2, 21,000. How many vCenter, VMware domain you can integrate with the ACI. So you can have 200 integration. How many service chains you can create, like the firewall and load balancer integration, 1,000. For the number of the VM, depends on the server scale. Total number of the this is the multiple fabric scalability. So maximum number of the fabric that can be stretch fabric, 3. Number of the router factor, 6. That's spine configuration. So number of the maximum port is 12. It means 12 data center you can bind. You can control from the API. As of now, it's 12. In the 6.0 version, that number will be changed. Cisco ACI 6.0. scalability guide. In every release, you will get a different scalability enhancement. You can see the number of the is 85. Previously, it was 80, right? 80. So in every release, the number will be totally changed. So if I go to the here, so number of the port is 25 now. It was how many? 12, right?
Yeah, 12.
It was 12. Now it is 25 because this version 6 also has new feature which we call the virtual APIC. These are the ALE and ALE 2 engine type which you can get from this version. And these are some devices which support that version 6. So it also requires some specific version, some specific switches which has version 6.
So this version means basically the OS only, the ACI OS, which will be loaded on the Leaf and Spine system, right?
Yeah. So this is the hardware capacity because version 6 is a major release for the CISCO. Not all hardware supports the version 6. Only specific hardware, specific ASIC type supports the hardware, your version 6. Any leaf which has ALC, leaf spine engine and LSC2 with generation 2 only supports the version 6. Any switches which has a ASE and ALE will not be having this version support. Okay.
Fine.
So this is the scalability. So I think this has huge improvement. The 24 port itself is huge. You can have 25 data centers, which is very unlikely for the data center. Keeping in 25 places itself is a big deal. But most of the customers do that. For example, if I take the if I give the example Rakuten, if you know that's Rakuten, India Rakuten, right? That's a Japanese telecom for 5G, and they have around I think 12 data centers. 12, not 12. I think they have 17 data centers for ACI.
Okay.
And which includes that RDCs. Yeah, so let me share some of the. I'm sharing these links also for scalability, just to make sure that you guys all view that. So this is the one of the use cases. Means they have around 10 DC and 7 RDC, remote DC. Remote DC means rather than in the site itself, for example, you have the multiple towers available in the regions, right? Geo tower or some other tower will be available for the all the user traffic. There also you can deploy that Cisco ACI like with the one spine to leave something kind of stuff you can do that. But yeah, those are the biggest ACI deployment which I know is Rakuten is a client in Japan across
10 data centers and 7
RDC, remote location DC. Remote location DC is equivalent to the sites. Okay, they have that the telecom infrastructure, which is this is the data center, right?
Right.
And they have the towers, the remote towers, where the user get that, right?
Right.
Tower for the telecom. Right. And these towers usually interact with the data centers. In between, when tower get the your traffic, they come directly into the one DC, then they transmit into the main DC. That we call that RDC, remote DC. Okay. So
Okay.
Cisco sold them as the ACI solution for here also and for here also.
Okay.
Here they have all the bunch of servers which are available. all the services, for example, EPC services and all other 5G services which runs, they are running inside the data centers, and all the traffic, user traffic coming from here, which is strange to see that, to be honest, for me. But yeah, this is how Cisco have sold the solution.
Because what are the factors we need to consider when we plan for a spine upgrade? What are the possible reasons to go from 2 to 3 or to 4?
Is your the scalability. If you want to upgrade the spine, that will be totally based on your scalability requirement. If you
Is it only the port density when it's fully occupied? That's the only
port
thing?
density, it's not about the port density. You also have to consider the throughput.
Okay.
If you're having so suppose you have 100 leaves, okay,
Right.
in a port 1, and with 2 spine, and so those 100 leaves require 10 to 15 TB throughput.
Okay.
In this case, those spine must have the ability to control the 10 to 15 GB of the throughput. If 2 spine are unable to handle that, then you should be considering the introducing third spine or fourth spine. That's one of the consideration. Second consideration is if you have the, if you have the lower throughput, for example, you have 100 leaf switches with the 1 gig or 10 gig information, and throughput is fine, just port is the issue for you. That's also second consideration you can have there. Okay. But also consider that always throughput is the main consideration. And how you can consider that throughput? So if I go to the Cisco Nexus 9500 or 9300 spine datasheet, you should be getting here how much traffic it can handle of that particular model. So there are very rare chance when you go for the your modular chassis. If you are using this particular model number, it can support this much terabyte of the bandwidth, right?
Yeah.
If you're going with this particular model number, it can support this one. So it's really depends on the use cases, what you have, and what you want to use. Okay, these are the
So I think the APIC controller must be displaying this information on what is the load traffic.
Sorry, come again.
Saying on the controller, we will be able to view the utilization on the this thing trunk link with the spine and the leaf, right?
Yes. So from the controller itself, you can check that how much, what is the capacity of this scalability of this particular one device overall the fabric. So there is 2 types of scalability. Okay. So major concern is overall port scalability. Okay. Second is a node scalability. That's the second thing is. So you should be focusing on the overall capacity of the fabric rather than focusing on the device base. That's the difference ACI brings. If you have the legacy infrastructure, you focus on the per hardware based scalability, right? But in ACI, you don't consider per node based scalability, especially for the leaf switches. You consider overall leaf switches capacity. If you have the requirement of if one node is supporting like 500 endpoint, what is the overall capacity of your endpoint? 5,000, for example. So that's the main consideration. Okay. Because ACI work as a solution. It's not any device. It's not the one kind of individual standalone. It's a solution which you integrate with your data center, and you integrate all the endpoints, whether it's any VMware or your servers with this solution, and that solution managed by the controllers. Okay. So what is the APIC here? We have talked a lot about the APIC. APIC is just a policy control. It's not the control plane. It's not a data plane. So APIC does not have any sort of traffic in its plane. It's just a server which you brings while configuring the ACI, and that through that server you can install the one image. So suppose you have one C series server, Cisco C series server, Cisco C series UCS server. You cannot randomly pick any UCS server and install the API. No. Cisco has two types of server, right? B series server and C series server, UCS server. Cisco said that, okay, no problem. I am going to, from C series server, there are a specific few model. I am going to dedicate those model number for the ACI solution. Just like the Nexus 9K devices, Cisco dedicated this for the ACI solution, right? SDN solution. Same thing, Cisco said that I'm going to use my UCS itself. I'm not going to create separate hardware. On the existing hardware, I'm going to reserve few model number for the ACI solution. And on top of those hardware, I'm going to install the APIC image, which is a SDN controller image. And that SDN controller will be used to control these 9K devices. Okay, so these are the two hardware which Cisco use for the APIC configuration. If I go here and check that what APIC hardware we use here, Cisco APIC hardware. Hardware support matrix. If I go to this one, if I go this one, look here. So Cisco said that this is the model number. Cisco UCS 220, M4, M3, and L3. These are the some model number we have, which hardware model number which we have for the your APIC support. If I go to this one, this is how they looks. If I open this, yeah, this is the APIC how APIC looks. This is just a server. They have this much ports available for the connectivity with the your leaf switches. And on top of that, you just install that ACI APIC image, and you control this APIC remotely, and you configure from, if you want to trigger anything, if you want to configure software upgrade, hardware upgrade, if you want to do anything, you just tell this APIC, and APIC will perform on behalf of you.
So what is the baseline OS on the server?
Also, this is the Linux. Okay, baseline is Linux, and the second option on top of the Linux, there is we call that CIMC. BIOS, you can see that BIOS is HOS something is there, but the baseline is Linux. I will show you that. Okay. Baseline image is the Linux image. On top of the Linux image, you build that your ACI. Okay. And different model number. For example, if you're purchasing this model number, you have a specific ports that will be reserved for the connectivity of the your Nexus devices, Nexus 9 devices. Can you use this APIC for the controlling any other devices? Answer is no. You cannot use this APIC to control non-Nexus ACI devices. Okay, that's only limitation of the APIC. So if we go to the APIC, it's a Cisco UCS C series server, only designed for and 9K ACI image. Okay, that's we call that SDN, software defined. Now, if you want to control other network, for example, if you have N5K and 9K or N7K devices or at least router. Initially, when Cisco was discussing a lot of SDA solution, DNAC solution, Cisco aim that time was APIC EM solution. That APIC EM was the purpose of APIC EM was to control the all the Cisco product. So Cisco, before they introduced the DNAC or something else, Cisco said that I'm going to design one global SDN solution. From that SDN solution, you can connect to any device, whichever you want to control: firewall, Nexus, Catalyst, ISR, WAN, ASR, everything you can control. But later Cisco realized that something is not the a success solution. That's why Cisco categorized that solution with the SDA separately, and the APIC for the ACI, and for the FTD and all the ETCs for the other things. Now, Cisco has another major solution which we call the orchestrator. It means if you're having the SDN controller, suppose if you have the SD access and API, right? And you further you want to automate your infrastructure. Cisco said that okay, no problem. I have orchestrator on top of the SDN where you can deploy the master SDN device, and that master SDN device can control this SDN controller. Okay, that's we call that UCS director.
UCS director.
Yeah.
Okay.
That's orchestrator solution. It means that controls that all the solutions. UCS director. Cisco is also developing that Nexus dashboard. Okay. Nexus dashboard, but that dashboard is not that mature. They are trying to integrate Nexus as well as the ACI with the same box, but that solution is not yet mature. Okay, they are still figuring out a lot of things. So UCS director is still the orchestrator which controls that all the SDN device.
Vijay, this APIC EM which you talk about, is it the? I heard that it is the same ACI solution for the enterprise. Basically, the enterprise module is the word, right?
So that's why APIC EM was initially designed for all the control to control all the products, not only for the enterprise. Then later they converted into the DNAC. Okay. Later they converted APIC EM into the DNAC solution, which we call the SDA.
Okay.
Okay, that they have converted. So they saw that this use case is not valid for the customer. You cannot design one controller to control everything. So they have converted. They have shifted their focus individually for the specific products.
Okay.
Okay.
This UCS director which you talk about, is it it's different to the NSO orchestrator which Cisco also have?
Yes. You can say that NSO is another solution, but NSO is again for the NFV solution, network virtualization solution. Okay.
Okay.
Not for the all the solution, but the UCS director. If you want to deploy the NSO, you need to know that ML language, and you need to know netconf. You should have knowledge. You should have the knowledge of the automation. Without automation, you cannot deploy the NSO. That's simple. But for the UCS director, there's a graphical interface basis. You can use the graphical interface to deploy that as well as the automation, both the options. So before NSO, UCS director came in the picture.
Okay.
Okay. You can have the Cisco lab also for UCS director and NSO. I will be giving you overview for the NSO and UCS director for the automation.
Okay, great. Thank you.
Okay. So let me go here. So these are the some model number we have. Like in ACI, Nexus 9000, we have generation 1, generation 2, generation 3, right? Similarly, ACI has 3 generation of the APICs. So generation 1 has this model number L1, M1, L1. These are the model number. L means large, M means medium. What is the difference going to be between them? It means memory wise. Memory and the storage will be totally different. For the medium, suppose if you have the less than 200 devices, right, in your infrastructure with the 3 APIC nodes, you can go ahead with the M1 model number. If you have if you're a telecom infrastructure or you have around huge number of the devices, leaf and spine, you should always go for the large L model number. So L3 and M3 is the latest generation 3, which you should be considering that, and with the large CPU, medium CPU, and memory. These are the only differences going to be. Apart from that, functionality wise, everything will be the same. But it's going for the L1 and M2 doesn't matter. Okay. So for each hardware, okay, so let's talk about the connectivity. So when you purchase your leaf switches and your spine switches and your APIC, leaf, spine. Okay. So between leaf and spine, on the spine switches, you will have the reserve port. 6 reserve port will be for the spine switches. Doesn't matter which model number you purchase. 6, this we call the fabric port. Fabric. You have to connect spine to that port only. On the spine switch, is there any reserve port? Answer is no. Because this model number is specific designed for as a spine. You don't have any reserve for the leaf switches. You can use any port to the leaf. But on the leaf side, you have the specific port which you have to use between spine and leaf connectivity. We call that fabric port. And these other ports, we call that EPG port or access port or non-fabric port. Okay? EPG, endpoint group ports, or configuration port, you can say non-fabric port, you can simplify that. Why we have 6 fabric port here? 1, 2, 6, 4, 5, 6. Because how many spine switches you can have? What is the limitation of the ACI? 6 spine switch per port, right?
3 controllers, 3 spines we can connect it.
Yes. So each port going to the 1 spine switch. That's a maximum number of the spine you have. That's the reason you have the 6 reserve. Okay.
Okay.
But now I think in 6. version switches which have 6.0 support also support the 12 spine switches. Okay. If you see this one, this switch also support that 6.0. So that's the reason you have the hardware, specific hardware for the specific version. For the APIC, that card we call that weak card. And is there any port reserved on the leaf switch for APIC connectivity? Answer is no. You can use any EPG port, any configuration port for the APIC connectivity. Either can be copper, either can be your fiber. This is the 10 gig interface. Can you use lesser than 10 gig interface? Answer is no. You cannot use 1 gig or 40 gig or 100 gig. You should be using the 10 gig interface between the APIC and leaf connectivity. Okay. Between leaf and spine should be minimum 40 to 100 to 400 now. Okay. Minimum 40 gig interface or 100 gig interface you have to use between leaf and spine. And that should be fiber only, not the copper. You cannot use any that's the reason. Even if you're purchasing the copper port switch, these are the RJ45 port switch. If you see that these fabric ports are SFP ports, right? That's the reason Cisco had said that you need SFP port, you need fiber connectivity for scalability, for the better agility of your infrastructure. The scalability and the point of view means if you are using the fiber ports, you can extend to the 500 meter, 1 kilometer, or 200 meter using the OM3, OM4, right? Cable type. But if you are having the a copper port has some limitation for the length.
Right.
Okay.
Is there any just one question? Is there any option given by Cisco in certain condition we can use normal access ports also as a leaf ports?
I haven't got it one. Come again.
Like you said that there are predefined ports defined as leaf ports, right, to connect to the spine.
Yeah.
Spine ports, whatever. Sorry, I forgot the exact name.
Spine, a fabric port.
Fabric port, sorry. So, is there any option in certain conditions the normal ports can be programmed as fabric ports?
Yes. There is a conditions, but the design will be totally different. Let me discuss. Okay, I was about to discuss.
Okay.
This one you have design. Leaf, sorry, spine 1, for example, and spine 2. And this, for example, I'm using 9236 L series, okay? 9336 or 64 you can use anyway. I'm using 93180. Okay, 93108, not 92, 93. And then I'm using 93180, for example. Now, this has the specific 6 port reserved. Okay, for the spine connectivity. Fabric port. Now, Cisco said that another solution. Let me bring 3 nodes. I am, for example, I am using the 3 controllers. Okay, this is the, I would say, APIC 1, APIC 2. This is the UCS server. Okay, and APIC 3. Sorry, APIC 2. Yeah. Okay, these APICs have the 2 ports. One port going to the one switch, another port going to the one switch. One port going to be one port, another port will be going to the. This is the best practice. Can you connect just one port? Answer is yes, you can connect. But best option is to connect the 2 ports in any of the leaf switches. Okay, it doesn't matter. It has to be for a specific leaf. The one port will be active, one port will be the standby. One port will be active, one port will be standby. Active and standby. This is the by default nature of the APIC. You cannot change it. Now, second use case is this is the, for example, you have the 10 gig to 40 gig port. Okay, 40 gig switch. You have the requirement saying that, you know what, I don't have the 40 gig ports. I'm going to purchase one more switch. Okay, one more leaf switch, leaf 3, and which need 100 MB requirement to 1 gig to 10 gig requirement. This is my requirement, and I don't have 40 ports. SFP, right? SFPs. Now, second use case is don't have space in spine. Okay, this is the another use case. It means if suppose you don't have the a 40 gig interface available with you and you don't have the enough port in spine, what flexibility you have? You can use leaf to leaf connectivity. Any port, for example, 1/10 interface. Here you can use 1/34. This interface you can use. This design we call the tier 2 design. Tier 2 design. And this is we call the tier 1 design. This ACI and this tier 2 discovery and this switch also will be controlled via the APIC. So APIC perspective, physically they are connecting like this, but logically it will form the neighborship with this one.
Okay.
Okay, this is we call the tier 2 design, multi-tier design in ACI. But to be honest, is this the best option? I would say that it's okay if you have space issue something. Just because of SFP, you should not be considering this design, because this design has interdependency. If anything happened to this device, this will also be down. Okay,
Right.
so do not heavily involve with this design. That's the best option we have, because usually this design Cisco sell in Nepal customer, who has less budget or something. I've seen that in Nepal customer, they have this 90% of the customer in Nepal, they are using this design, tier 1, tier 2 design.
Means like in case there is a requirement, suppose there's a port, faulty port, or there is an increase in the traffic towards the spine, and we need another port to connect to the
No,
spine.
so on the leaf switch, you cannot use any EPG port as a spine. Okay. However, you can use this fabric port as a EPG port.
Okay. Otherwise, it's possible.
Yeah. You cannot use 1/10 as a spine, but the port which are here, and suppose you have all the ports are 10 gig ports, you need 240 gig ports, right? And you have just 2 port utilized and 4 ports are left. You can convert those ports into the EPG ports, and you have to reload that device in order to convert that. Okay, you have to change it, and they have to reload your device in order to reflect that change. And then after, you can use as a EPG as a 40 gig or 100 gig port if you have requirement. But there is an issue with that also, okay? Because if you sometimes reload this while during the upgrade, if you want to reload this device, sometimes these ports creates the issue. Recently, I faced that. I had two ports as a APG port we had converted, and we upgraded to the 5.0 from 4.2. Okay, in this case, this fabric port were not working for 5.0 version.
Okay.
40. So sometimes it can be the buggy, but especially I'm sure about the 5.0, but in 4.0 it works totally fine. Even in 3.0 it works totally fine. Okay.
All right. Thank you.
Cisco ACI multi-tier. Let me show that multi-tier architecture which I have. Multi-tier architecture. Okay, this is what I have. These are the leaf switches. This one is the leaf switch. Okay. This is how you can connect that. So your APIC will be controlled. This device also, this device also, this one also. So you need minimum this version.
And does the connectivity to the tier 2 will be through the fax, or it will be direct?
It will be direct, not a fax. It's a direct connectivity.
Okay.
And these are the Nexus 9300, not the fax.
Okay. So if you're using a legacy switches, in that case you require that.
No, it's not like that. This use case is to have this device will be also using the ACI image. Okay.
Yeah.
ACI image.
Means
ACI
if
means
you're
this will
connecting
be
non-ACI, then you require the fax.
no fax requirement is something else. Okay. Fax requirement is something else. Fax requirement is if you extend that few ports, if you require few ports and you don't have budget to purchase these devices, 9300 devices, then you can go for the Nexus 2K devices. And that's one of the use cases. You can see that port extension. Apart from that, I don't see any use cases for faxing. Okay, fax will be brainless. It will not have any routing table, anything. So and also you cannot control via the fully configure and do anything routing protocol configuration on the fax. If you have the servers, then you can use the fax. If you want to have the layer 3 devices, right, you cannot use fax. There is certain limitation on that. Okay, these devices which are supporting tier 1, tier 2, both. You cannot use all the devices for all the connectivity. Okay. Go to the here again. Okay. Any confusion on the APIC? Or I explore more on that?
Yes.
Okay. So we'll talk about the APIC overview and the ACI connectivity. This is how your ACI looks. Okay. This is I have 3 APIC nodes, which is going to be in a cluster. You have to connect this APIC as a cluster. You cannot use APIC as a standalone. If you are using the single APIC, for example, if you have one APIC, how many leaf and spine you can have? I think 2 or 3 maximum leaf and spine you can have to a single APIC. Why only 3 APIC? Why not 2? Why not other number? Because of the database replica. Database replica. In database, it's always best practice to maintain the 3 copies of your data. That's the reason we have 3 APIC, nothing else. To maintain the failover of your database. If you're having the 3 APIC, even if one down, the majority copy will be available and that won't be having any issue. If in case 2 APICs will be down, the database will be react some differently. To prevent the data loss from the database, they come up with a 3 APIC concept. That's a totally database based concept. Which database your APIC use? MongoDB. MongoDB.
Is there a continuous heartbeat connectivity between all 3 epics to check the other tools are available?
Yeah. That's I will discuss that. Okay. What we are getting from APIC, what we are getting? We are getting the fabric managed will be APIC. All the configuration exposed via the API. Switch join the fabric in few clicks. The functionality wise, we are getting no spanning tree. We are getting the ECMP. We are getting the dynamic configuration. We are getting the whitelist model. Whitelist model means any to any will be denied in API. Nothing will be allowed by unless you want that. Okay. What are the configuration we are getting? So in between leaf and spine switches, this is the 40 to 100 gig, and this is the 10 gig interface. So all the configuration between leaf and spine will be deployed via the APIC itself. It's a predefined configuration in the ASIC level itself. The moment you install, the purpose of Cisco to deploy to design this UCS C series 220 240, they have hard coded some configuration on the APIC. They have hard coded some configuration on the APIC. The moment APIC discovered these model number, hardware model number and devices, APIC tried to push the configuration. What configuration APIC push here? Layer 3 configuration, VXLAN configuration, BGP, ISIS. These are the configuration which will be pushed from the APIC itself. Can APIC push the by default the endpoint configuration? Answer is no. By default, configuration will be pushed between the leaf and spine. Which configuration APIC push? ISIS, the routing protocol, BGP, and VXLAN. These are
the all IP configuration will be automatically defined.
Yes. Okay. So let's talk about the what configuration it push that APIC push that. Okay. So when you configure the APIC, you configure the here. APIC act as a DSCP. Okay. DSCP server, where you define the pool of IP address range. Okay. The moment you say that this is the DSCP server, these all the leaf switches act as a DSCP client. Okay. And discovery, the moment first time you bring this API, it will run the LLDP protocol everywhere. So which protocol? Two protocol used for the discovery. First is LLDP. Second is DSCP. These are the two protocols which will be used for the discovery process. If you disable the LLDP on the switch or leave or the API, the discovery won't be happen. That's a by default inbuilt feature. Okay. How does this APIC assign the IP address to these leaf and spine? You have to tell the APIC. Suppose you configure the DSCP pool 10.0.0.0/16. You are telling this APIC from this range. If spine is requesting any IP address, just assign from this range. So APIC will be distributing this APIC your IP address using /32 value. Okay, which I will cover. No worries. In detail how this story works, I covered that. No worries. For each leaf and spine switches, APIC assign this value /32 for communication. Once the APIC assign the configuration for IP address to all these devices, then you can able to communicate from here to here and here to here. Okay. And how APIC maintain the database synchronization? APIC sends the keep live message to all the leaf switches and spine switches to maintain its database up to date. Which protocol it use, what and how it use? APIC use infra VLAN concept for the keep live. If APIC want to communicate with these leaf and spine switches, APIC automatically along with the IP address in the DSCP, APIC also deploy the VLAN ID. If you defining the VLAN ID, that's well and fine. Otherwise, APIC itself has 39 something one. I forget the range. There is the one VLAN ID which will be deployed here. That we call that VXLAN ID, infra ID. For that, what is the purpose of using that infra VLAN ID? To make that communication between the APIC and the leaf and spine.
Right.
Okay. This much is clear?
Yeah, that's clear.
Okay.
Vijay, one question: why exactly we are connecting our APIC controllers to the leaf switch and not to the spine?
Okay. So a spine work is to perform the core routing. Okay, core routing. Leaf has all the database, all the endpoint connectivity, as well as spine by default has the 100 gig or 40 gig ports. Okay. Whereas APIC needs just 10 gig ports. That's the two use cases I can think of. Other than that, that's a hard-coded Cisco design. I really can't say that why specific reason. Only Cisco can tell that.
Okay.
I haven't found anything apart from that two reasons.
And why this Cisco proprietary? It's just curiosity I'm asking. Cisco proprietary discovery protocol is not used, and the LLDP has been used in this.
Yeah, so the reason is APIC has also third-party support. So with the APIC you can control the VMware. Okay, with the APIC you can control the Palo Alto. With the APIC you can control the F5. These are some third-party devices. They do not support CDP, right?
CDP, right? Correct. Understood.
That's the reason LLDP is the standard protocol which APIC uses.
Got it. Thank you.
To considering that other vendor as well integration, because ACI is not just a device; it's a solution for the data center which has a lot of feature apart from the SDN stuff. You can control from APIC. You can control load balancer, firewall, VMware, everything you can control from.
Right.
Okay.
Thanks.
Yeah. Now, if you talk about the here, what functionality APIC adds into the fabric. The first thing is a layer 3 network runs. So by default, we talk about the fabric. In between, what protocols run here? Protocols. VXLAN as an overlay. Then it runs the IS and BGP for underlay, as well as it use MPBGP EVPN for control plane, and it also use multicast for data plane BUM traffic, broadcast unknown multi-destination traffic. These are the protocols which will be by default running between the leaf and spine. Who puts that protocol? COOP. COOP protocol is also one of them. Okay. What is the full form of the COOP protocol? That a council something is the one.
Council of Oracle something.
Yeah, Council of Oracle protocol, something like Council of Oracle protocols. Okay. These are some specific protocols which will be by default deployed between the leaf and spine during the fabric setup. Can you modify anything? Answer is you can only modify time and matrix. Can you modify here? You can see define the route reflector. Can you modify here? IP range. Can you modify here anything? No. Can you modify here anything? Answer is no. By default, this is the predefined. Where this configuration you get that from APIC. In APIC itself, this configuration is inbuilt. You say this is the ASIC level. The moment LLDP sent to here and the try to then once the APIC say that okay, I got one LLDP request and requesting for DSCP. APIC will say that okay, let me register this device to my table. Once the registration is done, APIC will try to assign this configuration on where? On fabric ports. APIC will not assign this configuration on any other ports. APIC will identify that okay, this is something fabric port you have. Please install this fabric, all the configuration on all the fabric ports. Okay. This is how the fabric or protocols run in the ACI.
This
Now,
multicast DP is the dense mode you told?
No, that's not the dense, that's not the sparse anything. Okay, that's the multicast for the leaf and spine BUM traffic. That's for the layer 2 traffic and unknown layer 2 traffic, unknown layer 3 traffic. Okay, sparse mode is for the where you have IGMP request. Okay, this is not the IGMP request. This is for the data plane communication. Here we don't have IGMP traffic. Here we don't have PIM traffic because why not? Because PIM protocol is not supported here on the spine switches. So you cannot have the sparse mode here. Okay, that's the pre-inbuilt tuning which CISCO has provided without PIM. Okay. Now let's come to the APIC now. So suppose you have the APIC. confusion for the connectivity or anything before I move to the actual APIC stuff? If not, okay. Now, if you talk about the underlay and overlay, so ACI is totally VXLAN based. What is the VXLAN? Why not VLAN? The reason is VXLAN has multiple advantages and multiple advantages over the VLAN. VLAN, how many VLAN you can create? 4,000 something, right? How many VXLAN you can create? 16 million. 16 million segment you can have inside the family. That's the reason VXLAN is better than the VLAN. Now, second is why this is not the only reason we use VLAN, right? VXLAN is the overlay protocol. Why? What is the overlay? It needs underlay to work. Underlay protocol. Underlay layer 3 protocol. Okay. So without layer 3, VXLAN cannot be work. It's a layer 2 over layer 3 protocol. It also uses UDP 47. So VXLAN is a layer overlay protocol which works over layer 3. It means if you want to run the VXLAN between the two devices, make sure that you must have the routing enabled between them. Because why routing? Because it's the overlay protocol, not the underlay. Overlay means tunnel technology, VPN technology. Which VPN? L2 VPN. L2 VPN technology. So VXLAN is another is a L2 VPN technology. That's the reason if you see here, MPBGP EVPN we are using. It means by default, you cannot send any layer 2 traffic over the BGP, right? By default, you cannot send that. So in order to send the layer 2 traffic over BGP, you need to have the EVPN address family because BGP has around 15 to 16 address family. One address family is standard address family. Second is extended. Extended means the moment you say that I am going to run the extended address family for the BGP, that's where the BGP becomes the MPBGP, multi-protocol. It means BGP is running with the other protocol also, which we have layer 2 VPN, which enable the layer 2 routing in the BGP. In order to support the layer 2 routing in the BGP, you run the EVPN. For which specific reason? For VXLAN. That's the only reason. Why VXLAN? For this EVPN, because without EVPN, suppose for example you don't have the BGP in your ACI. Okay, in this case, what protocol is available? By default is ISI is enabled, right? ISIS and multicast. In this case, VXLAN will work as a layer 2. Flood and only data plane will work. In order to make the control plane is what? Routing. It means you have the reachability, you have the gateway. In order to put that suppose you want to put 10.1.1.1 and 20.1.1.1. In order to make that two communication, you need to have the control plane communication. That means you need to have the routing. In order to have the control plane communication, you need some sort of protocol. Either can be BGP, either can be other protocol. But for the ACI, it's a predefined BGP. We use that because of the scalability.
Okay.
Okay. That's the only reason to enable the VXLAN for the control plane. You use MPBGP EVPN as a as the underlying of control plane protocol. That's it. Okay, there are multiple advantages and disadvantages of that.
How does it differ from a normal L2 VPN connectivity?
Layer 2 VPN has some limitations. Okay, layer 2 VPN cannot be extend certain VLANs more than certain VLAN. Okay, suppose if you are using the OTV, one of the second technology, layer 2 technology, how many VLAN you can extend from one DC to another DC? 256 something. But suppose you have the 1000 VLAN, suppose you have 1000 IP address. You want to enable that 1000 IP address, you want to stretch across the 2 or 3 sites. Is it possible to do any through other protocol? Answer is no. The scalability is the major problem for the other layer 2 technologies. For those technologies are designed and introduced to have it as a temporary solution. Suppose one server is sitting over here for the VLAN 10. Okay, and you have 10.1.1.1 and same VLAN server sitting in DC2. This is in US, this is in India, DC2. And you have the VLAN 10. And you want to use the same gateway 10.1.1.1. Which technology you use? The layer 2 technology, right? To stress that network. And which layer 2 technology you can use? Layer 2 EVPN something you can use, but there are certain limitations on that. You can use L2TP something technology, OTP technology, but there are certain limitations on that. So what VXLAN is solving is a scalability and mobility. You have the better mobility than the other technology. Mobility means you have the unlimited stretch network across the multiple sites. Okay, if you compare with the layer 2 with the layer 3, so VXLAN has two types of mode. One is the flood and learn mode. Second is the VXLAN EVPN. Flood and learn means without BGP, MPBGP, EVPN. Okay. If you want to use fabric as a layer 2, suppose you want to use ACI as a pure layer 2, you don't want to have any external communication. Use that layer 2, but it won't be, you won't able to create the gateway. You will able to create the gateway though, but you will not be utilize that gateway without the control plane. So you will have the no control plane. It's going to be data driven flood and learn based on the MAC address communication. It has a the issue is a limited scale, limited workforce mobility, centralized gateway issue, and security issue. These are some issues which you will get from the flood and learn. When you come with the VXLAN EVPN, you are increasing the scalability and stability. You are also optimizing network mobility. You are also having the distributed anycast gateway. It means one gateway across the multiple data centers. You are also increasing the security. Okay. I hope this clears that VXLAN. But the thing is, you need to know the VXLAN basically. Okay. If you don't know, guys, the VXLAN concept, I would highly encourage that I have uploaded some VXLAN basic video for the NXOS. Okay, so you can let me paste that link. And this one, VXLAN LAN and the uncontrolled plane. This is the pure NXOS base, not the ACI. But if you want to really understand how VXLAN works, I will highly please at least watch one time. You may get some idea. I'm pasting this link into the. Okay.
Thanks.
Because if you want to troubleshoot anything, you need to understand the VXLAN. Without understanding of the VXLAN, it will be hard for you to understand what is the number, because ACI between the leaf and spine, everything is all about the VXLAN. VLAN is not allowed from here to here. Between leaf and spine, only VXLAN. VLAN is allowed till the port here. Once the port traffic, once the traffic is hit on the port, the VLAN will be translated into the VXLAN.
VXLAN.
Okay, that's the reason. And all the communication, it's not like suppose you have the VLAN 10, right? And you have the test VLAN, you have written that name itself will be converted into the VXLAN ID. So everything is, number-based communication happening. Everything is math here. Okay, there are different type of VLAN ID assigned here, and those ID I will be discussing that. But I hope this is the basic you clear that. Okay.
So for basically a layman purpose understanding, if we connect two machines or the same subnet to two different leaf switches, one or two, so they can work directly as a local LAN without any L3 routing enabled.
Yes.
Between the two leaf switches, right?
Yes. So if you
Using
have
the
the
VXLAN.
VM1, VLAN 10, VLAN 10, like 1.1.1.1, 1.1.1.2. If you do not have the BGP running between leaf and spine, still you can communicate that. But the moment you will say that 1.1.1 need to communicate with the 2.2.2, you need to have the control plane route. Also, if 1.1.1 want to communicate with the internet, in this case also you need to route. So for external communication or for the inter-VLAN communication, inter-subnet communication, you need to have the control plane. Okay.
Fine.
Right. Can we take, guys, 10-minute break and come back again?
Yeah, sure.
So, let's come back after 10 minutes. Hey guys, I'm back. Everyone is there?
Yeah, we have.
Okay. So let me start with the APIC. Okay. So let's say that this is all the APIC functionality. Okay. So APIC performed all the protocols. So if you see that there is ISIS routing protocol, why the APIC choose the ISIS protocol? Why not OSP or why not PIGI? Because the reason is for ISIS also maintain the MAC-based routing. MAC-based routing. And ISIS most scalable protocol than the OSPF and the EIGRP. And OSPF and EIGRP cannot support MAC address-based routing, whereas ISIS does have ability to support the MAC-based routing. That's the reason ISIS is a default protocol which runs between the leaf and spine. Okay. Now, if we talk about the APIC stuff here, okay. If you talk about the APIC, so APIC has a multiple way to control it. The first way of APIC is to configure is just here. If you have the one APIC node, okay, this is the APIC node. APIC can be controlled in various ways. Okay. Okay. This is the user interface. First is CLI. APIC can be controlled via CLI and XOS format. APIC can be controlled via the bash mode, Linux mode, because base image is Linux. Second is API can be controlled via the graphical interface. Fourth, API can be controlled by the REST API. In the REST API, you can use that Python, Ansible, XML, Postman, Ansible Tower, anything, SDK, many interfaces or many languages can be used for the REST API configuration. So APIC is not something like, if you know, APIC say that if you know that Python, okay, no problem, I can support the Python. If you know the Ansible, I can support the Ansible. If you know the Terraform, I can support the Terraform. If you know the Postman with the XML and JSON, no problem, I can support it. If you know the SDK with the Python or any other language, no problem, I can support that. APIC has open source API supports. It means any third party, anything you can integrate, APIC has ability to accommodate those API, REST API interface requests. Okay, this is how broad APIC configuration or user interface is. That's the reason this is the most successful SDN solution in data center. Okay, there are multiple open source SDN controller available, but when you call that SDN controller, most of the time we refer as a control plane, right? Because if you talk about the SD-WAN, in SD-WAN, we have the control plane acting as a vSmart. But here we are saying that you have the SDN controller, which is only policy controller. It means it can only manage the policy. It can only tell that, okay, VLAN 10 is, I want to configure the specific switch. It will configure the VLAN 10 to the specific switch. If VLAN 10 is not working on a specific switch, it will not impact the SDN. If SDN having any kind of issue, it will not impact any control plane data plane traffic. That's the advantage we are getting in the APIC level. Whereas if you compare to the other SDN solution, especially in the market, those SDN solutions work as a control plane. It means there are interdependency between the devices and the control plane. When you have that kind of feature or nature of the devices, you will be having an issue for the high availability. Okay, so let me open that box. Let me open another.
How does this NX format and the baseline Linux different CLI?
Okay, so when you configure the API, okay, so suppose you want to run the show VLAN. Okay, you cannot run so VLAN from the baseline, and if you want to run the MO query, okay, API based query, if you want to extract some information, you have to run MO queries from the baseline.
Okay.
Okay, if you want to configure the VLAN from CLI, you can configure VLAN from CLI, but you cannot do it from bash node,
Bash mode. Okay.
right? So you can say that bash node is for the queries, for the show commands, and NXOS we can use for the show command as well as the configuration.
Okay.
Okay. Now, when you first time bring your cluster, when you first time you bring your APIC nodes, what else you have? What first time you do that? This is your box you got there. You got one box and you have the two spines, two leaves with one spines. This is basic setup I have. Okay. This is the spine I have. This is the leaf. This is leaf. Leaf one, leaf two. The first thing is you connect these leaf devices with the controllers. APIC. And once you connect that, what you have to do here is there is multiple interfaces of the APIC. First is your ACI interface. Then you have two different interfaces. Out of band interface. Okay. Then you have the CIMC interface. Then you have other different console and management. This is the CIMC, Cisco Integrated Management Controller, just something. I forget the full form. And this is the out of band.
Okay.
And this is the ACI. This ACI interface, fabric interface. When you first time bring your APIC, you connect the CIMC interface. We also call that KVM interface, keyboard monitoring mouse something interface. Keyboard video monitoring or mouse. It means if you want to configure APIC, you have to connect your APIC first time to your CIMC interface. How you connect that? Just give me a second. I have the APIC. Okay, so for fabric installation. So first thing what you do, you initialize your APIC CIMC. In the CIMC, what image you install? You make sure that your host images or Linux image is perfectly fine. This is the base image of the APIC. Oh, sorry, your controller. It means if you're bringing the one laptop, in your laptop, first thing what you do? You install any app? Answer is no, right? If you want to install, for example, uh, uh, Google Chrome, do you install directly on your mobile? Answer is no. You have the Android or iOS running on top of that. Then you install the Chrome on that, right?
Okay.
Same thing. When you purchase the box, you install the base image. Then on top of the base image, you install the APIC image. Once the APIC image is installed, then fabric installation happens. Discovery. In the APIC installation, you configure the cluster details, everything. Okay. When you first time bring your nodes, what you do? There are few steps in that. First is CIMC, then APIC installation, fabric discovery, then ACI and NXOS, whatever you want. Okay. The CIMC. Suppose you have the one box. Okay, let me open my lab one by one. Okay, just give me a second. I will show that things. And just give me a second. Let me get one lab also. So I will show that what exactly should be happening. I have two lab. I will go for the 5.2. Okay, not 6 dot. So okay, so I will connect the CIMC interface. So I already have the CIMC. Okay, I have already configured the CIMC. This is the ports of the CIMC. Just give me a second. So when you first time connect the CIMC interface, you do not directly have the IP address, right? In order to configure the CIMC interface, the first thing you do, either you bring your laptop and configure your laptop as a DSCP. If you do not have laptop and your data center does, so because in some data center they do not allow the laptop anything, right? They provide you that. Just give me a second. Something is wrong with my login. Okay. So first thing is when you bring your devices, either you connect your laptop to this interface. Okay. When you bring the laptop, you make sure that your laptop is configured as a DSCP and assign the IP address to this one. But if in case you do not have laptop options, what you're gonna do here is second option is available. You connect your KVM. It means you connect your monitor through the BZM cable. You connect your mouse through the USB cable. You connect your keyboard through this interface. Keyboard, mouse, then monitor. Monitor, keyboard, mouse. This we call the KVM interface. This is the second option you have. If you have the first option is always best option. You can assign the DSCP and you can just connect using the DSCP IP address and access the graphical interface. Through the graphical interface, you can log in through the IP address. If you do not have the IP address, then you have to log in through the CLI. This is the base management of IP address. This is the out of band management. This is the two fabric port which will be reserved. If you are using the C220 M4, this place will be different. If you are using the C240 something, then this place will be different. Some switches, some APICs will have the copper and the SFP port both. Some APICs will have only copper ports. Based on your requirement, Cisco give you that feature. Okay. APIC. CIMC. Let me log into the CIMC interface. I do have the APIC CIMC. Let me trying to get that.
CIMC is also a kind of a RJ45 port only, right?
Yeah, it's a RJ45 port which you can connect to any of the your devices and try to do the SSH or telnet, whatever you want to do that. But telnet is by default disabled for all the servers. Okay, so let me log into. I have the login of the CIMC interface. Okay. So this is the CIMC. When you first time, I have what I have scenario. I have connected my laptop to this interface. Okay, either laptop or you can see that one thing, you can connect to the one switch and you can configure this switch as the DSCP. Okay, DSCP. and you can try to access through that. I have first option, I have this port connected to the one switch, and on the switch I have connected my laptop. Okay, through laptop I'm trying to access this interface. And through this interface, I will try to launch the KVM. Okay, and this CIMC has multiple types of versions. Okay, what versions you have? Either based on the APIC image. If you have the APIC 5.x version, then you need to have the CIMC of the 4.0. If you have the APIC 4.0, then your CIMC can be 3.0. So it's also compatibility stuff. If you have the compatibility, if you want to upgrade the CIMC and or APIC, you have to check the compatibility. What is the full form of CIMC? CISCO Integrated Management Controller. Okay, this will have by default admin password, but I have different password because this is my production lab.
So it's CIMC is nothing but a kind of a ASDM kind of software pre-installed to access it, right? And it has all its versions.
Yeah, you can say that. Yeah, you can say that it's a it's SDN stuff, but
well, it has its own version, and the baseline controller has its own version.
Yep. Just give me. Yeah, okay. I've logged in. So first time when you logged in, this is how you see that your name is CIMC. Okay, this is my 4.x version, latest version which I have. If I go to the about, this is a host name. If I go to the here, this is my 4.1 version I have. Your graphical interface might be different when you're using the other versions. Okay, if you see here, this is the summary of the server saying that this is the APIC L2. Okay, this is the serial number of the device. This is the series of the device, 220 M4. Okay, this is the IP address of the CIMC. This is my firmware version, and this is the detail of the chassis. This is the utilization of the CPU and memory. Okay, now if you go to the left side corner in the Hamburger one tab here, you will see the chassis, compute, networking, storage, and admin. These are the multiple sections which are going to be available. Okay, now if I click on the chassis, which is chassis summary, you will get all the server related details. If you go to the inventory, you will get that interface related details. These are the CPU I have. I have this much CPU, which is as L2. If it is L3 something, the CPU and memory will be number of the threshold will be changed. I have two CPUs here. I have this much is memory. Okay, these are the memory deep card which I have. If I go to the PCI adapter, these are the week 212 25 I'm using. So what is this interface? This interface role is very important in the ACI. If I go to the here, if I say that CISCO APIC 220 M4 L2. If I go to the data sheet of this one, if I go here, yeah, look here, embedded NIC. In the embedded NIC, you have to select while purchasing the embedded NIC, not this one. Just give me see. I will say that hardware requirement. Before you proceed for anything, you should know that what exactly you're trying to configure. If you see that this is the model number and this is the ports. In each port, this is different role. If you see the two PCI slots, Slot number this one, this one. This is the slot which will be used for the ACI connectivity. So there is a two slots. Either you can ask Cisco to give you that copper port, either you can ask Cisco to give the fiber ports. Okay. If you are using the fiber ports, there is a specific weak card which is available for the ACI specific configuration, which is one is the week 12, 25, 12, 20 something is there. Okay. And week, where is week? Installing server. Week. Let me search that week. Maintaining the here we go. These are the M4 model number with the IO drive card. This is the minimum CIMC requirement, and where is the week here? Okay, these are the cards. Look here. If you see here, M4 support these cards. Either you can go with the 1225T, 1225, different 1385, and a 1227, 1227T. These are the PCI's card which has the minimum support and slots and the slot type, integration manager type. Look here. So you have to be very careful when you order that what slots you need, what type of SFP you want to use. If you want to use SFP plus, do not use SFP plus model part of this one. This model does not use that. Look here.
Basically, if we want a fiber port, then we will be getting a PCI interfaces. If
Yes.
we want normal copper, then it will be RJ port.
Yes. But what, because each NIC type is different, they have different price on
Okay.
that. Okay. So you have to order the latest one.
Okay.
13
But
is
the same
the best.
DHCP functionality can be enabled on the PCI also, right?
Yes. We also call that riser 1, riser 2, which is a NIC 1, NIC 2. Okay. Same thing I have here. Here. I have HBA, which is storage, but I have one riser card. I don't have two. Okay. And this is the 10 gig slots, CNA adapter.
You have two fiber ports basically.
Yep. This is the power supply stuff. This is the to make sure that when you purchase the APIC, you should have the true two power supply for the active and backup. Currently, if you see that I have just one, say that non-redundant. There is no HA for the power. If any outage happen to one PDU, everything will be down. This is network adapter. This is the 1 gig network adapter for what? For management. Okay. This is storage. I have this is storage locally for all the configuration saving, TMP, then CPU inventory. This is just a physical difference. The main is if I go to the compute, you will see the BIOS section, right? In the BIOS, you will see if you're having the server, the server does not, you cannot just upgrade one version and you are free, right? If you are getting the BIOS, server has multiple components on it. What components? NIC BIOS, out-of-band BIOS, your RAM BIOS, your CPU BIOS, lot of bundle will be integrated inside your BIOS version. Okay. So when you upgrade your CIMC interface, you have to upgrade everything. You cannot just upgrade single stuff and you're free. If you see here, memory configuration, all the configurations are there. Different settings which you do not need to touch by default. So what you have to touch here is, main thing is BIOS main thing is you should have the KVM properties enabled. If you have the KVM properties enabled, it means you can launch the KVM without connecting the keyboard monitor here. Okay. If KVM is disabled, what VKVM is disabled, it means you cannot get the CLI access for configuration. You have to connect the monitor keyboard here. If you do not want to connect it, you want to utilize VKVM, you can use that. This is the option.
And how do we do that? How VKVM will work?
So KVM is, so for example, if you want to configure anything, okay, suppose you want to configure the APIC cluster or ACI image you want to install. By default, if Cisco is not giving you the ACI image, for example, how are you going to install the ACI image on the server? You need some interface, right?
Right.
You install through the KVM. KVM is to centralize your interface for all the configuration, all the server management. Whether you want to run any app, whether you want to run any upgrade, whether you want to configure the cluster, everything you have to do from the KVM interface.
Well, do I need to connect some pen drive or a
No.
disk?
No. So there is two KVM. One is the Java. If your laptop is supporting Java, that's fine. Otherwise, HTML is also supporting. Okay. So you do not need to worry about the other thing. KVM is an inbuilt feature for these devices. You do not have to do anything. Okay. How you launch the KVM? That's the important thing, right?
Yeah.
For that, I go to the networking. Networking, this is the major part. If you go to the networking, you see the LLDP option, right?
Right.
This LLDP option must be disabled. If you're having the one APIC here, right? And you connect to your leaf switch. CIMC label, it means NIC label. LLDP must be disabled. The reason is when you enable the APIC image, APIC has LLDP feature. It does not use the physical CIMC LLDP for discovery. If this is enabled, the discovery process won't be working for you. So make sure that when you purchase the box, when you upgrade or downgrade, this LLDP CIMC label should be disabled. And ACI image label should be enabled. Okay.
Okay.
How you check that? I will show that. Okay. This is saying that on this NIC, LLDP, I'm going to disable it. If you enable it, discovery immediately will be stopped. You will not be able to discover leaf and spine switches. Okay. These are the 10 2-gig ports which I have connected.
So by default, you are saying the APIC controller LLDP will be in the disable mode, and it will not going to discover spine and leaf.
No, it depends. It depends on the APIC to APIC. In early generation 1, this used to be case, right? Now in generation 2, this solution is matured. By default, Cisco give the disable mode for the LLDP for the CIMC. Okay. However, if there is any issue or there is any discovery by mistake, Cisco sometime also give that with the enable mode. You have to cross verify everything. Suppose
the reason you are saying it should be in a disable mode, because if it is not in disable mode, the DHCP functionality will not work. Right?
DHCP is not related to the LLDP. Okay. The reason I'm saying here is CIMC. This is the server LLDP, not the ACI LLDP. If server LLDP and ACI LLDP is class in the same interface, the server LLDP will be always with, not the ACI image.
ACI.
Right? ACI image has some set of prerequisite. Make sure that physical label should be disabled. So I should run my protocol rather than using the physical protocol which is running.
Okay, fine.
And LLDP CIMC label is a physical label protocol. It's not the something which ACI supports.
Okay.
Okay. Any confusion so far till here? I'm going slow here because I know that this is very important point for the APIC cluster on for all the things. Okay, so here we go. Let's give me a second. Yeah, and this is the admin. And admin, you will not be able to do a lot of things. If you want to upgrade the CIMC something, you can directly upgrade from here. This is the firmware. Okay, if you see that running firmware, backup firmware, and the bootloader firmware and all these things, you will see that. This is also running like weak firmware and RAID firmware, all those things will be there. Okay. If you say the utility, you will get a lot of options here, which are not our use. Yeah, this is the one of the things. Now, second thing is how you get the CIMC. This is the graphical interface where you configure the ACI, right? If you see that right side in the corner, you will see that launch KVM, right?
Right.
From the CIMC interface, you can, what you can do, there are multiple functionality. You can reboot, you can shut down the hardware, you can configure the ACI, you can do the upgrade. Upgrade for what? CIMC
CMC.
and APIC image upgrade. You can do from here. You can configure the cluster, APIC ACI cluster. APIC cluster, you can say that. APIC cluster. You have to do the initial ACI configuration. Initial ACI configuration. All the things, these subtasks will be done from the CIMC. Okay. If I launch the CIMC, launch CIMC, this is how page will looks like. Saying that KVM server has accepted. Click on this one. So I'm just clicking on this. It will launch the one interface. If I go to my theory part now, here, not here, this one, this one. Once you connect the interface, this is the CIMC interface using the monitor. Okay.
Okay.
Monitor interface. If you are using the monitoring, you do not have the DSCP something, you can just simply connect this and you have to press the F2 button on your keyboard, right? And once you put the F2 button, you will get the option to modify the CIMC IP address gateway, and you will get the option to configure all these properties. Okay. Set the password and all these things. Then you press the F10 to save the configuration. This is without laptop. Okay. Once you connect that, you just access the CIMC, and you, by default, this is the username password it use. It might be different for different versions. Okay. Once you have the CIMC, yeah.
Which is just one point. What I understood from the KVM is that I just put my keyboard, mouse, monitor connecting to this EPIC controller,
Yes.
and just power it on. It will have any window OS, whatever window 10 or whatever 11 running, or I just power it on, and automatically some screen will come.
Yes. So you do not have to use your desktop. You need to use your monitor.
Monitor.
Okay. How you connect the VGM cable, right?
Yeah, correct.
So the moment, and here the server will act as your CPU, right?
Mm-hmm. Okay.
The moment you
will
on that power on the server, and moment you will put that F2 in your keyboard, the server initialization will be automatically shift to the edit mode.
Understood. I got it. Okay. So there is no need for a CPU or anything. Just connect the monitor, and automatically switch.
Your server itself will act as CPU. Okay. Now, if once you log into the CIMC interface, the first thing is what you do. You configure your host name, time zone, NTP, all these things. For my case, I have already configured this. Let me minimize this. For me, already I have configured this. Management. sorry, not user. Communication services. Look here. I already have all the details, SNMP, SSH, all these things are already enabled. IBM, LAN over something. A lot of things are already enabled there. But before, if you do not have the options, you can still do it from graphical interface itself. You know, configuring the host name, all these things will be, you can do it from here. It's not a big deal. But once you've done that, once you've done the CIMC, right, console, sorry, where I was, where is going? Okay, once you're done with the CIMC interface, you will log into the graphical interface and you will launch the KVM console. Okay, KVM console button you will be seeing. I have the 4.1 version, so if you see that this KVM is coming right side of my console, right? But this is the older version. This is the, I think, 2.x version. I have a snapshot. That's the reason it's showing here. Just give me a second. Yeah. Okay. This is the 4.1 version. If there is any issue, so earlier what used to happen here is, and if you have the KVM in your laptop, in initial days, you should have the Java installed, right? And you to download the JNPL file, then you have to renote a lot of things you have to do that. But now Cisco given the flexibility saying that you do not need to consider about the Java natively in your, you do not need to install Java in your laptop. You just use the graphical interface, which is your HTML page, and you will be able to perform all the tasks which needed. Okay. This is just a compatibility stuff. Now for the ACI initialization, the first thing is you do not log into the any leaf or spawn anything. You just make sure one thing: when you purchase the box, you should have the ACI image. ACI image. If suppose you have the NXOS, you have one box, Cisco delivered to you, and it has NXOS, which is mostly happen. What you have to do? You have to convert NXOS to ACI. How you do that? There is a certain command which you have to do that, Cisco NXOS to ACI conversion. This is the basic upgrade and downgrade process. What you have to do, you have to set boot from the NXOS to the to your ACI by default, which boot takes that. If I log into the APIC, for example, let me show that. You can see that. If I say show version or DI, DIR boot flash. You will see here, I have ACI image installed, right? In a boot flash, I have ACI image here. But if you Cisco is giving the box with the non-ACI image, what you have to do? Show version. In the show version, VSH. You will see that I have kickstart and system image and saying that you have the ACI image now. If you don't have the ACI image, you have the NXOS image. How you convert that? You have to install the ACI image. You just type that this is the new box, for example. Once you say that, okay, my box is running the NXOS mode, I have to convert into the ACI. Make sure that boot image is a ACI rather than NXOS. What you have to do? You have to upload the ACI image first in the boot flash. Either can be from the SCP, BSCP, from anywhere, wherever you want. Then you have to boot the ACI image. Rather than putting the NX OS, you have to say that boot ACI image on the switch itself. Once you've done that, you have to reload. After reload, you will be able to see that ACI version. That's a simple step. You have to just type boot and this image once you upload this image into the boot flash. Now, there are multiple types of image version you have. So let me, when you go for the imaging, this is the Nexus image, okay? Nexus image. When you have the Nexus image, there is two types of Nexus image. Okay, one is Kickstart. Second is your system. This is for the legacy NXOS. NXOS legacy. Now, in the modern NXOS and the earlier when you used to install, when you wanted to upgrade the ACI image, you have to do the two types of upgrade. Kickstart upgrade and system image. This is the base Linux image. Then this is the feature image for the NXOS. There's two types. That's the reason there's two types of image. And in old 5K and 7K devices, we used to upgrade two images. We used to download two images and upload two images. Now Cisco said that I'm going to introduce bundle. It means you just have to download the NXOS. Within the same image, you will get the two different bundle. You do not need to download, you do not need to upgrade anything. Everything will be in the same image. You just have to type one time upgrade that. This is much more easier than your two image, separate image. Same thing happened with the ACI. When you download the ACI image, you will get the single image. Inside the single image, you will get the system, you will get the Kickstart. What is the Kickstart? Kickstart is to make your hardware compatible for your features. Suppose you have the one hardware, right? Nexus 9K devices. The base image is running a Linux or load or anything. Because when you purchase the box, it does not have any image. It just has the port and all these things. To make this port in order to make any port in use, you need to have the driver, right? In your laptop, how you make you have Wi-Fi port. You need driver to install that, right? In order to make that interface in use, you need to have the driver. That driver is your Kickstart image for all the ports. Then this Kickstart image also is a way forward for the feature image. If you want to enable any feature on the port, that feature must be integrated with the separate image, which is called that system image. The reason is to keep the two separate images. If anything happened to the individual port, it should not be impacting the system image. So that's the reason there is a correlation between the Kickstart and system. All the feature VXLAN, OS, VLAN, all the feature will be available in the system image. Okay.
Okay.
Same thing is here. ACI. You have just single image, right? And here is showing that system image and boot flash image.
It's a kind of a package we
It's
need
a package
to install basically to start our ACI image.
Yes. It's not only the ACI, but the NX works also. You can also check that CISCO software. If you go to the software here, you will type the Nexus. In the Nexus, just download. I will say that yeah, it's Nexus. You will see a lot of Nexus devices, right? Which one you want? I want Nexus for this model. Go to this model. You will see that NXOS image and ACI image. Okay, and if I go to the NX or this image, say that this is the ACI image you have, and this is the bundle. Which one is you have to install? You have to install the win file rather than the. So if you see that, if you have this image for the Nexus 9300, Cisco said that if you are going ahead with this image, make sure that APIC is running this image. Okay, if you are going for this image 4. version, okay, Cisco said that if you are going with the 14. version, you make sure APIC is running this one. So there is an intercompatibility. You have to consider that. Okay, for each leaf, spine, and the APIC. Leaf and spine, same ACI image can be installed in the leaf and spine. Forget about this one. Okay, this is just a model number. You can install this image in any leaf and any spine. If once you've done that, Cisco suggests that you should be upgrading your APIC as well. Or if your APIC is 5.0 version is running, then Cisco suggests that same ACI should be running the 15.0. If your APIC is running 4.0, ACI should be running 14.0. Okay.
Okay.
So once I have launched the KVM. In KVM, where is my KVM? I have this KVM. Let's relaunch it. Let me relaunch it.
So basically, before we kickstart, there are a lot of upgrades and all checks are required, right? Not only on the device level, but on the APIC controller level.
Exactly. It's not like you just bring device and do everything.
Yeah.
This is the basic checks. It might see as a longer, but as a like whole, it won't be take much time. Okay. When you first time launch the KVM interface will show like this. This will show like this. It will say that you configure the APIC. Suppose you do not have APIC image. Suppose you do not have APIC image. How you install the APIC image? How you do that? You have to select the media, then you have to create the image. Then you have to upload the APIC image. Once you upload the APIC image, it will automatically reboot and give you that APIC prompt.
Okay.
For me, APIC image is already installed here. Okay. If you do not have APIC,
how does this all upgrade and all this works? Which you are like.
Okay, this is not the upgrade. Okay, upgrade I will discuss separately. This is not the upgrade. This is the first time when you purchase the APIC. If APIC, your server doesn't have the APIC image, for example, if server do not have any APIC image, in this case, you have to install the APIC image, right? How you do that? You launch the KVM, you go to the virtual media and create the image and activate that image. iOS image, you can see that.
Okay.
And which one iOS image is? This one is iOS image, right?
Right.
This is the one of the way for the APIC. If you want to upgrade the CIMC, same thing you have to from CIMC also. Here also you have to drag and drop CIMC version. How you get the CIMC version? You just have to type here. If you go to the here, type the CIMC. I will say that C2. You have to type the server M4. Then you can see the host utility option, right? This is the CIMC version. I will say that Linux. Yeah, this is the one. This is the CIMC image. You can see that. Utility, host utility image is the CIMC image. Okay.
So
you have
maybe by some other means, we need to actually put this APIC image in some folder in the device before actually we can access.
Either you can, either you can use the USB. Okay. Either you can use as a like drag and drop from your desktop, laptop, whatever you use that. When you use KVM, use the USB for the connecting your image upload. If you are using the laptop, use the your desktop image file.
Okay.
Okay, but this is how you first time you bring up the APIC. APIC upgrade, downgrade is different thing. I'm not focusing on that for now. I'm
Right.
focusing on the how to bring up the APIC. Once you bring up the APIC, this is all the configuration you will get. First thing is APIC. Once you, if suppose you already have the APIC image, okay, this is how KVM will launch. Saying that first time, I'm press any key to continue, starting the setup utility. Then it will say that okay, I need to configure the cluster. If you're having the 3 AP, you have to do the same thing for all the 3 AP. Okay. Then you have what you have to do here. You have to configure the name of the fabric. Suppose you have the DC1. What is the DC1 name? I will say that S bank, for example. S bank FB1 fabric 1, right? I can give that fabric name. So there is a criteria to follow that for the cluster. So if you have 3 cluster node, okay, so all the 3 AP must be using the same fabric name. They must be using the same number of the controller. Then controller ID can be changed based on the numbering. This is APIC 1, 2, 3 based on your requirement. Then APIC name can be here different. Here if you see the tab address, this is the infra tab, internal tab. If you see the infra VLAN ID and multicast. If we are configuring the 3 APIC cluster, all the 3 APIC nodes should be matching the same exact this information. What information it should be match? Fabric name, controller number, tab address, infra VLAN, and this. This and this can be changed.
Yeah.
There is 1, 2, 3, 4, 5. If you are configuring the cluster, your management IP can be different. It's not a big deal. And one thing you have to notice here is APIC 1, 2, 3. You have to configure password only on the APIC 1. If you type here APIC controller number 2 here, APIC controller will not ask the password. APIC 3, if you type 3 node, APIC node number 3 won't ask the password. It will automatically sync from the APIC 1.
Okay.
Okay, how they sync that? We'll discuss that. Okay, these are the major 3 criteria. What is the tab pool here? This tab pool we use for that as a DSCP, right? All the leaf and spine switches will be getting the IP address from this range. What is the recommended range? 16/8/19/22. These are the /24. These are the recommended slash value which is Cisco recommend that for the tab. The reason is why the too much range, because one switch, one leaf and one spine requires at least in the overall, I would say that 4 to 5 IP addresses. 4 to 5 IP addresses. Minimum.
One switch.
One switch, yep. For different purposes. What are the IP address? I will be discussing that. Okay. So for if you're having the 200 devices and each device is getting the 2 to 4 to 5 IP address for that, how many IP address you need? A lot of IP address, right?
Right.
In this case, that's the reason Cisco said that always use /16 or 19. This is the best practice for that. Even if you want to in future, if you want to expand your cluster, something like that, it will be always useful for you. Okay. So now let's go to the here. I already have the configuration of the node. So let me log into that. This is the APIC 1. Okay. Let me show that the configuration. This is the APIC. If it's a ACI DAY AV read aviation vector application vector, show me that configuration. If you see that a lot of this page is showing the very strange, right? Now, what I will do here is I will SSH this CIMC interface to give you that better background. Just okay. Okay, okay, let's wait. Let me increase the font. You can do SSH. Make sure that SSH is enabled. If you do not have SSH is disabled, then you cannot do the SSH, right? How you identify that whether SSH is enabled or disabled? Through the CLI, through the graphical interface, you can do that. Through CLI, how you can do that? Graphical interface admin. I think I found somewhere here. One for service protocol. Just if I go to here, admin and communication services, you will see that SSH is enabled, right? If you want to do SSH, make sure that SSH is enabled. If I go here,
what is the IP it is using to access it? Like you are doing the SSH, right? So
CIMC.
CMC.
Yes. Yeah. If you see that this is the server model and
serial number.
Someone we have not given any host name. There's a reason it is showing like this. If we have to have changed the host name, this name will be changed. If I say that, show me the configuration AV read ACI. I don't think AV read will work here. AV read, that's the issue. Okay, so what I will do here is I will log into the APIC itself. I will show that AV read. AV read means I will show the properties what I have configured for the cluster. Okay. Okay, so this is the APIC fashion ACI DAY AV read application vector read. What is the meaning of FNP read? I will be discussing that in depth. If you see that, it says that this is the local appliance 1, but there is appliance 2, appliance 3, APIC 3, APIC 2 also. If you see that APIC 1, what configuration it has? Saying that this is the tab pool IP address. Okay, this is the tab pool range which has been assigned. And if you see here, APIC, there is a node ID also. Okay, so you're saying that this is the node. Cluster ID must be there here somewhere. It's very, confusing if you see that this screen is black and there must be the out of band IP also. And there is one more command to check that all the details. Just give me a second. What is the command for that? I think AV read. Yeah, AV read. Just type AV read. You will get most of the information. AV read. Yeah. If you're saying that this is the fabric name, this is the total number of the cluster, this is the version of the nodes, this is the IP address assigned from where? From the pool, tab pool. Okay. It means when you create the tab pool, APIC itself assign the one IP address to APIC 3. From one pool, APIC itself will assign IP address from that tab. Okay, and that tab pool, that IP address we call the in-band. Using this IP address, APIC form the communication. Okay, APIC does not use out-of-band for communication.
Sorry, come again.
When you configure the tab pool in the APIC, right? APIC
Right.
assign that tab from the tab pool. Suppose 10.175 for my case, 0.0/16. So if you have three APIC, each APIC will assign 10.75.0.1. First three IP address to all the APIC. 0.2, 0.3. These are the in-band address of the APIC. Using this IP address, APIC internally communicate with each other to form the cluster, as well as APIC use these IP address to communicate with these leaf and spine switches and assign the IP address from this page.
And this pool is different from the CIMC pool, right?
Yes, CIMC is just server management. It has nothing to do with your other stuff. Okay, from this pool, tab pool, DSCP pool, the first three IP will be assigned to all the three APICs.
Controllers. Right.
Okay. Then apart from this IP address, other IP address will be assigned to all the leaf and spine switches. And these are just out of band, not need to worry about that. Okay. If you see the
just one question, just in case our controller or a leaf spine switch get reboot, is there any aging factor which is come into play that the same IP will be assigned?
Okay, so APIC has database. Okay.
Right.
I will share the Faisal, I think he's dropped next to video. I will share the video recording, okay, to you guys, including today. So when you go ahead and what you were asking, I forget that. Sorry.
Basically, in case a leaf or spine or a controller get reboot, whether the same IP address.
Yeah, this is the APIC. In APIC, APIC has 101 node, okay, connected to it, and this 101 node is rebooted. And until unless you change the name of the node and the node ID, APIC will not assign new IP address. Okay. If APIC is getting the same node ID, so same node ID and the host name and serial name, APIC will maintain the one database saying that doesn't matter how many times you reboot, whether you remove or re-add, as long as my node ID, serial number, and host name is matching, I'm going to assign the same IP address, because this is reserved for you. APIC create the one reserved table in the DSCP pool.
Okay.
Okay. If you change the 101 to the 103 serial number, node ID, then in this case, APIC will override and assign the new address to you.
And it same follows for the leaf and spine switches also.
Everywhere. Because the thing is, if you reboot every time and APIC assigns every time new IP address, this might be blunder, right? Because APIC and spine, leaf and spine form the BGP and OSP, ISIs and other protocols neighbors. It will be the issue.
That's the point coming in my mind that every time it's a bombardment of the configuration podcast.
Exactly. It's not possible. Okay, so if I go to the SO controller details, you will get that lot of details, what has been configured. Okay. Yeah, look here. Saying that controller 1, this is the host name, this is the IP, this is the fully feed. If you go to this one, this is the detail of it. I think there is one command which I need to run that in order to get the tolerance. But anyways, yeah, this is the details of the APIC. Now, if you want to check the same thing from the graphical interface, you can check that. Okay, but if you want to check from the CIMC, this is how it will miss, right? You have to configure it manually. So the first time when you bring up the APIC, this is how the interface will show that, saying that a cluster configuration. Then you have to define all the configuration one by one. Okay, this is how we define that. Saying that host name, if you do not want to give the any customized name, it will automatically select the ACI fabric one. Okay, by default is 3 API. So you define that how many nodes you have, what is the name, what is the VLAN, and this is the default, VLAN ID for the infra VLAN. Okay. Once you're done with this one, then APIC will start the discovery. If this configuration is not done, then APIC won't even start the discovery. Okay.
And we need to enable the LLDP, you said, right?
Yeah, LLDP is by default is enabled. Make sure you disable LLDP
While doing
for APIC level, it's already enabled. Okay. Now the rest of the part I will be resuming next week. I'm going slow for this initialization phase. Once initialization phase, we understand properly how discovery works, how what kind of issue you can face. I'm going to teach troubleshooting as well. I don't want to repeat the troubleshoot in next class. That's the reason I'm going so one by one. What could be the potential reason for the issue? Okay, then I will show you that all the discovery, how to register and all. Okay, guys. Then we'll see you next week. Then I'm stopping class here.
Thank you.
Okay. Thanks, everybody. And I will upload the video and I will send to the Vijay and the Soumya. Okay. From them, you can get the link and download the video.
Okay. Thanks.
Sure. Thank you.
Thanks, everybody.
Thank you, Vijay.
Okay. Thank you.